All right, here's Algebra Week 5. We got worksheets every day here and Test Friday. Again, here's my email if you have any questions. All right. We are on 10-7, which is repetitions. Repetitions are permutations with repetitions. Again, a permutation is where order matters. How many ways to arrange something. So again, just review. If I had, 4 people in a line, number of arrangements, order matters. That would just be 4 factorial, which is 24. But now, so the formula for permutation, when the number available is the same as number needed, was n factorial. 4 people, 4 factorial. But when there's repetitions involved, it's still n factorial, but at the bottom, any letter that repeats or anything that repeats would go at the bottom. That doesn't mean there's only 2 things. There could be nothing. There could be 5 things down here, but usually books will just write 2 letters down there. But you'll see once we do an example. N again represents the number available. P, Q, and any other letter would represent repeated items. So for example, all right, let's say number of arrangements. These are the directions. How many ways can I rearrange the letters DAD? So you can see we have a repetition. We have 2 D's up here. If I flip the first and third letter, I have the same answer. So we don't count that twice. So the top would be how many letters there are. So that would be 3 factorial. And the bottom is any repetition. We have 1 letter that repeats twice. So that would be 3 factorial over 2 factorial. We could use the calculator if we want. 3 math PRB 4 divided by 2 math PRB, which is the left arrow, and there's the factorial key, and we get 3 for an answer. So there are 3 ways to rearrange that. And we could actually write them down. We don't have to, but I'll do it for this problem because there wasn't that many answers. So that's one way. The A could be in front, or the A could be in the back. Those are the only 3 ways to rearrange those letters. Let's try another example. How many ways can we rearrange the letters in the word parabola? So again, the top, we count up all the letters. There are 8 letters, so that will be 8 factorial. And then we look for any repetitions. I notice there are 1, 2, 3 A's, and nothing else repeats. So this would be 8 factorial divided by 3 factorial. Again, factorial means each number down to 1, the product. So like 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So the answer is 6,720. All right, let's do a really long one here. Let's do my last name, O'Keefe Betcher. We won't put in the apostrophe or the hyphen. We'll just use the letters. So we count up how many letters there are. There are 15, so that goes at the top. And then we look for repetitions. And it doesn't matter the order that you put these in the bottom, but I notice there are 2 O's. There are 1, 2, 3, 4, 5 E's. And 2 T's. Again, it doesn't matter what the order is at the bottom. But when I punch this in, 15 factorial divided by, remember this division bar is a grouping symbol, so when I punch this in, I do need parentheses at the bottom. 2 factorial, 5 factorial. Technically there's multiplication between those, but you don't have to hit the multiplication sign. Maybe in a TI 30 or 34 you do, but in a graphing calculator you don't have to. And that's a pretty large number. I think that's like 2,724,321,600. So there's a lot of ways to rearrange the letters in my name. All right, next example. Let's say we have 3 math classes to choose from, 2 English. Oh, these are not classes, these are books. 3 math books, 2 English books, and 5 fiction books. And like each math book is the same, each fiction book is the same, the 2 English books are the same. Number of ways to arrange on a shelf. So basically this is the same problem as up here. So what you could do is you can make it just like that by just writing the problem out. There are 3 M's, there are 2 E's, and there are 5 F's. So now it looks identical to the problems we did up here. So this is not a bad strategy. You don't have to do this, but if you want it to look like that, it would be. So either way, either I look here or look here, I need to find the total number. And there are 10 books altogether. And then what repeats? Well, we got 3 M's, and again, I could have got the answer from up here. 2 E's and 5 F's, so that goes at the bottom. Again, when you punch it in, make sure you put parentheses around the bottom. So we have 10 factorial divided by parentheses, 3 factorial, 2 factorial, 5 factorial. So there are 2,520 different ways to rearrange these books on a shelf. Now let's change the question. Let's choose one of each. Number of possibilities. This one's similar to a problem we did earlier in the chapter. Now we're choosing one of each. So now the first choice, I have 3 possibilities. The second choice, I have 2 possibilities. And on the third choice, I have 5 possibilities. We multiply these to get the answer. 6 times 5, 30. There are 30 different possibilities. And that's the first section. The worksheet that goes with that is right here. Yeah, might have to pause it to get the problems down. Okay. .8 is on probability and odds. Now we've been talking about probability all chapter, but odds is something new. So again, to review, probability is successes over total. And I can use the abbreviation. I'll just use S for success. And instead of writing total, I'm going to write S plus F, success plus failures. Either you succeed or you fail, whatever it is you're doing. All right. So we can think of this formula. So probability is success over success plus failures, which is the same thing as total. Where odds, this is a new definition, it's still successes. So the top number, the numerator, stays the same, but the bottom is not total. The bottom is failures. So S over F. So we mentioned that probability has to be between 0 and 1. Right? The probability of something occurring has to be a number between 0 and 1, where odds can be any number. All right, so the odds of whatever, the Milwaukee Bucks winning the NBA championship could be 3-2. So, but where the probability would be 3-5. All right. All right, so let's do a few examples here. Let's say we have a bag of 5 yellow marbles, 6 blue marbles, 5 white marbles, 4 white marbles. What's the probability of picking a Y? So again, probability is success over total. So the success number is 5. The total number, if we add all these up, 5 plus 6 is 11 plus 4 is 15. 5 over 15. We could keep the answer like that. If we want to reduce it down, it would be 1/3. But if I say, what are the odds of yellow? Now it's success over failure. So the success number is still 5, but the failure number would be these over here, which would be 10. The other way you can get 10 is you can just subtract the 5 from the 15 right here, but it's probably easier just to look, oh, there's 10 of them that are not yellow, and that reduces down to 1/2. Probability of not white, all right, this symbol means not. All right, so probability is success over total, so the total is still going to be 15. How many are not white? Well, that would be these two numbers, 5 plus 6, which is 11. What are the odds of it being not white? Again, the success number will stay the same, so that will be 11. The failure number would be actually the white number, which would be 4. 11 over 4. Or 11 to 4 is technically the way you want to say that. Convert from odds to probability or vice versa. So they'll put it in one, you put it in the other. So if the probability is 1/4, then what are the odds? So again, what I always like to think is, what are we doing with the denominator? The numerator is going to stay the same. So without thinking too much, I know the top number has to be 1. Now I got to figure out, what do I do with the denominator? What I like to think of is the probability denominator will always be larger, as long as there's no 0 involved, but will, for the most part, be larger than the odds number. You're adding two numbers together as opposed to just one number at the bottom. So I always want the probability number to have a higher denominator. So if the probability has a bigger denominator, to go from probability to odds, I got to make this smaller. And the operation that makes it smaller is subtracting. So I kind of mentioned like up here, you could have done the same thing, subtracting 5 from 15 to get 10. Well, that's kind of what you have to do down here. So I need this denominator to get smaller. Well, the operation that makes it smaller is subtraction. So we're going to subtract 1 from 4. So 4 minus 1 is 3. So we're either going to add or subtract, but when we go from probability to odds, we need to make this denominator smaller, so we're going to subtract. Whereas the other way, if the odds are 3 halves, then what's the probability? Again, without really thinking too much, we should know that the numerator stays the same. So I can write 3 immediately. Now I got to figure out what I do with the denominator. Again, if we remember that the probability will always have a bigger denominator, how do I get this denominator to be bigger? What operation do I do? Well, I need to add. So 2 and 3 will give me 5. And that's that lesson. The worksheet that goes with that is right here. Fairly short lesson. Okay, next one. Actually, the last lesson of the chapter. Probability of compound events. Now, we've been doing compound events all chapter. I might not have just called them that. Compound events is where there's more than one thing occurring. So if we flip 2 coins, or we flip a coin and roll a die, or we pick 2 marbles, those would all be considered compound events. Now in this section, we need to know a little bit of about a deck of cards. There are 52 cards in a deck. And again, we're not counting the jokers or any of those extra cards, but there are 52 cards in the deck. There are 2 different colors, black and red. So, which means there would be 26 of each. 26 black cards, 26 red cards. There are what are called 4 suits, and they are clubs, and each of these would have 13 cards. There are 13 clubs, 13 spades, 13 hearts, and 13 diamonds. If you add 13 4 times, again you get 52. Each suit has 13 cards. And those cards are ace, which whatever, it stands for 1 or sometimes 11, but there is no card, the 1, so it's just an ace. So ace, 2, 3, 4, 5, all the way up to 10. But after 10, they don't say 11. It would be the jack, queen, and king. So that's 13 different cards up there. And again, if there are 13 different cards and there are 4 suits, there are 4 aces, 4 twos, 4 of all of these cards. And again, 4 times 13 is 52. And then one other phrase that they use that we need to know is face cards. Face cards would be on a normal deck, just the jack, queen, and king. These are people. So they have a face of a person. So of the 13, 3 of them are face cards. Or in the whole deck of 52, since there are 4 jacks, 4 queens, and 4 kings, that would mean there are 12 face cards in a deck. All right, so let's do some examples. What's the probability of picking a face card? Again, probability is success over total. there are 52 cards in the deck. Of those 52, we have 3 different face cards, but remember there are 4 suits. So 4 jacks, 4 queens, and 4 kings. That means there are 12 out of 52. Now you can leave your answer like that, or you can reduce it down. The other way of getting it is you could just think of one of the suits. So whatever, clubs, there are 13 clubs. Of those 13 clubs, how many are face cards? Well, there would be 3. So this fraction actually reduces down to that. So either answer is fine. I guess this one's probably better, but either answer is okay. What's the probability of a red face card or a black card? Whenever you see or, you're going to be adding 2 numbers together here. So again, there are 52 cards. How many have a red face? Well, again, there are 3 different face cards, and there are 2 different types of red cards, the hearts and the diamonds. So you have the jack of hearts and the jack of diamonds. You got the king of hearts and the king of diamonds, and a queen of hearts, queen of diamonds. So that would be 6. All right. Or another way of thinking of it is there are 12 face cards. Well, half of them are red and half of them are black. So half of 12 is 6. So 6 of the 52 cards are red face cards. Or means we're adding. How many black cards are there? Again, 52 is the bottom number. How many are black? Well, half of them are black, so that would be 26. We're going to add those 2 together to get 32 out of 52. Again, we can keep our answer like that, or we could reduce that down, and that would be no. 8 out of 13. Or we could use the calculator too. Remember 32 divided by 52 math. It's already highlighted on fraction, and there's your 8 over 13. What's the probability of rolling a 2 or a 5 with 1 die? All right, so again, we are always assuming if it's a die that it's a 6-sided die, all right? So unless it says otherwise, it's 6-sided. So again, the bottom number would be 6. There's 6 different possibilities. We can get a 1, 2, 3, 4, 5, or 6. Chance of getting a 2 would be 1 out of 6. The chance of getting a 5 would be 1 out of 6. Since it's or, we're going to add those up. So we have a 2 in 6 chance of getting a 2 or a 5, which we could reduce down to 1/3. Now we're going to change problem slightly. What's the probability of rolling a 2, then a 5? So order does matter here. So again, we have 2 events occurring. So the first event, what's the chance of getting a 2? Well, again, there's 6 possibilities, and of those 6, we have 1 chance to get a 2. On the second roll, what's the probability of getting a 5? Well, again, there are 6 possibilities, and one of those would get us a 5. And if you remember from the trees, we multiply these probabilities. 1 times 1 is 1. 6 times 6 is 36. So we have a 1 in 36 chance of rolling a 2 and then a 5. what's the probability of picking a face card, then 2 with replacement? So what that means is we're putting the card back. It gets a little harder if you didn't put the card back, how to do these problems. All right, so again, we have 2 events. The first event is what's the probability of a face card. Again, there are 52 cards. Of those 52, we have 3 different types, but since there are 4 suits, so there's 4 jacks, 4 queens, 4 kings, again, there are 12 face cards in the deck. In the second event, again, we have 52 cards. How many 2s are in the deck? Well, again, there are 4 different suits, so there are 4 2s. We're going to multiply those. 12 divided by 52 times 4 divided by 52. We could always write decimal answers, but I like the fractions, so I'm just going to hit math, enter, enter. 3/169. So you could write decimal, you could round to 1 or 2 decimals, that's fine. What's the probability of getting a red face card, then black card with replacement? So similar to the last problem, we have 2 events occurring. The red face card, there's 52 cards in the deck. How many are red face cards? Again, we have 3 different kinds. There are 12 face cards altogether. Half of them are black, half of them are red. So half of 12 is 6. Second event, again, 52 cards. Since we're putting it back, of those 52, half of them are black, so that's 26. And again, we will multiply those. 6/52, or 6 divided by 52, times 26 divided by 52. Again, I could write the decimal, or I could hit math, enter, enter, to make it a fraction. 3/52. The last problem is a little bit harder. Probability of a queen or black card. It doesn't look any harder than the rest, but we're going to soon find out that this one's a little harder. All right, so again, we have 2 different things. Or, like before, means we're going to add. So, whatever. First thing, queen. We know there are 52 cards. How many of them are queens? Well, there are 4 different suits. So remember, there are 4 aces, 2s, 3s. There's 4 of everything, so there are 4 queens. Black cards, again, there are 52 cards. Half the deck is black, so there are 26. And then we add those together. So what's so hard about this problem? Well, if we look at it, a card can be both queen and black. So we have several black queen cards. So we've counted a card multiple times here. Now, if we look at the other problems we've done, there's no other or problems. We've done a few or problems. There's no way it could be both red and black, or you can't roll a 2 and a 5 on the same die. So in these 2 examples, there can't be any overlapping, any repetition. But here, you could pick a black queen. So we have to actually subtract both. So we're not counting it 2 different times. So we need to figure out how many cards did we count twice. So basically, how many black queens are there? Well, again, if there are 4 queens, half of them are black and half of them are red, there are 2 black queens in there. So 2 of the cards I counted in both of these columns. So I actually got to subtract 2 out of here. I don't want to count well, that would be the queen of clubs and the queen of spades. I don't want to count it twice. So I counted the queen of clubs here, but I also counted it here. Well, it's only 1 card. So we got to only count it 1 time. Same with the queen of spades. So anytime there's a repetition with an OR, we have to subtract it. Again, if we go back to the other 2 OR problems, it's impossible to draw a card that's both red and black. So I didn't have to subtract anything. It's impossible to roll 1 die and get a 2 and a 5 on one shake. You can't get both of them. You can only get 1 of them. But here I can pick a queen that is black. So we do have to subtract. So instead of it being 30 cards, it's actually 28 cards out of 52. And again, we could reduce that down if we wanted to. We don't have to, but. And that would be 7/13. And that's the last lesson of the chapter. So this is the worksheet that goes with it. And then Friday, we would have a review lesson, a review worksheet. I guess I could write all the topics. That's what I usually do. So there is a backside to this too. So here's the backside to the review. Let me write down the topics, even though it's very similar to that worksheet. This would be the Chapter 10 test review. I think every topic has multiple questions, so if I start, multiple questions. A lot of these kind of overlap each other. Permutations, that's where order matters. Combinations, that's where order doesn't matter. Little story problems, that'd be like how many people, 8 people, how many different ways can you put them in a line, stuff like that. Tell whether it's an independent or dependent event. Make tree diagrams.